This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 2 weeks. Thanks to our audience and the partners listed on our website for supporting the podcast. Welcome, listeners, to another episode of Software Engineering Radio. This is an episode that we do through Skype, and we hope Skype will work for us. On the other end is Shane Clifford. He works for Intentional Software, which kind of defines the topic for this episode, intentional programming, intentional software. Welcome, Shane.
Hi, Marcus. Thanks.
Okay, so why don't you introduce yourself to our listeners so they know who you are, and then we can talk about what you do.
I am the lead engineer for Intentional Software's Bellevue development team, and I've been with Intentional Software for close to 5 years now, and we've been working on our new technology for software development.
Mm-hmm. So what is that? 10,000 feet overview, and then we can go into details.
So Intentional Software is about doing domain-oriented or language-oriented development, and the idea is that we capture the contributions from domain experts, or experts in the field of the target problem for the software in a structured syntax.
Mm-hmm. So I mean, sounds to me like domain-specific languages.
Yes, it is domain-specific languages, but one of the things that Intentional brings is that it's all natively structured in what we call an intentional tree, and then using this structured format for all of the intentional languages allows us to be very expressive in the ways that we both edit and transform and generate code from that source.
Okay, so the general approach is basically from a very high level perspective, you capture things with specifically created languages, and then you generate code from that to make it executable. I mean, that's kind of what everybody does who does DSLs and model-driven development. So right. I guess there is this thing that your editor works differently, right? So it's not like people type in characters.
Right. So it's a structured editing environment. You are always editing the intentional tree and not editing a textual syntax that is later parsed or otherwise changed into an abstract syntax tree of some kind. We're always manipulating a tree directly in the editor, and then what typically you will be editing is a what we call a projection of the intentional tree, and this allows us to capture many different and very specific notations that apply to the domains in question.
Okay.
So that we can better represent in the editor the sort of native notations for the experts involved in that particular software system. Mm-hmm. For example, electrical circuitry or mathematical notations or these sorts of things.
So let's dive down on this a little bit. If you say mathematical notation, I mean, I can write x equals x plus 1. That's mathematical, but that's kind of boring. I can express that with ASCII. So in contrast to that, what kind of notations can you express or can you show or render or edit with this kind of approach? Can you illustrate that a little bit?
Well, we can do summation symbols for summation equations, integrals. We can show division as a horizontal line. These sorts of varied, much more close to what people would prefer to write by hand or look at when they're reading a textbook or a paper that's written in that domain.
Mm-hmm. So is it fair to say that if we compare intentional to other DSL stuff, that what kind of distinguishes your approach most is the extreme freedom regarding notation?
Yeah, that's certainly a large distinction. I think the other big distinction that we have is the underlying mechanism of the intentional tree, which allows us to represent many different aspects or parameterizations of the information, while at the same time editing projections. The reason we call the editing views that you see projections is that they really are just slices of that particular intentional tree for the purpose of editing in that particular notation. The underlying tree may in fact contain many other aspects of the software system being described that aren't represented in the particular projection that someone is using to edit with their favorite notation. So we may have, a very high level projection of a tree that has, just something very specific to a particular domain expert's area of interest, while at the same time that tree could contain, very low level programming information in other parts of the tree, and we can get into a little more detail about how that works.
So the intentional tree is different from, let's say, an abstract syntax tree in that the abstract syntax tree captures the abstract syntax of one language, whereas the intentional tree captures, let's say, everything, and then different views on that, different projections can be used to edit a certain aspect of this everything.
Correct. We create schemas in intentional software that apply to the intentional tree, but they do not define the structure of the intentional tree. Mm-hmm. All intentional trees have the same underlying structure at the lowest level. And what our schemas provide is a set of rules, if you will, for participating in that domain's capabilities, its projections, its code generators, its other transformations. Mm-hmm.
So again, if I contrast that with classical language engineering approaches, if you would, let's say, if you would have, classically speaking, one language to describe components and interfaces, and then another language to describe the implementation of the components, then in classical approaches, these would be two different languages, and you would refer, let's say, from an implementation block to a component to define what the implementation of that component is. In intentional, you can basically put all of that into one model, into one intentional tree. You don't have to have separate languages. You only have different projections to cater for what different stakeholders, developer roles need.
Yes, that's certainly true. Frequently, we do have separate languages as well. It's just that we're not, a single intentional tree is not constrained to only participate in one language.
Right. So the schema doesn't define the storage structure or anything. It's really just a view or a way of interacting with this data.
Precisely, and the fact that it doesn't define the storage structure is very important, because it allows us a lot of flexibility in being able to extend and grow languages or add new aspects of a system into a tree over time, mm-hmm. without disturbing or otherwise impacting the already existing functionality that's represented or the information that has already been captured.
Yeah. So what is the structure of the intentional tree? What's the abstraction of describing the tree?
So the intentional tree is made up of something we just call a node, and each node, nodes form the intentional tree in a primarily hierarchical relationship. Mm-hmm. So we have a node, and then each node has fields.
Okay.
And the real key here is that there's no constraints on the number of fields that a given node can have. And all fields are strongly identified, and all nodes are strongly identified. Mm-hmm. And so within each field of a node can be one or more additional nodes. So that forms the basic hierarchy of the intentional tree. Now, the other key to the intentional tree is that the way that nodes and fields are identified is by reference to other intentional nodes.
I guess you need to explain that.
So we have a node in a program tree, for example, representing an addition equation. Let's say 1 plus 2.
Mm-hmm.
So the top node in that tree is plus.
Right.
And then it has, let's say, a field for its left argument and a field for its right argument.
Mm-hmm.
And the left argument field contains a node representing 1, and the right argument contains a node representing 2.
Okay.
Now, clearly I'm going to want to have many different pluses in a given intentional tree.
Right.
So there is another intentional tree that contains the definition of plus, that describes what plus is. And the plus node in our 1 plus 2 gets its identity, it's what it is from that by referring to that other node that represents the definition of plus.
Okay,
which in turn references something a node in the system we call def, which is how we describe or define nodes in the trees.
Mm-hmm. So this gets its identity by, or is described by, sounds to me a little bit like the classical instance of thing, right? The plus
right.
Here is an instance of the concept or the meta class or the whatever plus.
Yes, it is an instance of relationship, and in fact, we call the relationship an is a relationship.
Okay.
And then fields are similarly identified by reference to other nodes.
Okay. Good. So I guess I guess people can imagine that. Well, I hope so, and there are certainly some videos online that illustrate that, and we link to those. That if you have complete freedom regarding the notation, that you can do quite some impressive things, and we'll discuss examples later. But let's first address the question of how you actually create languages. I mean, if I'm a developer who goes to a customer who works in the XYZ domain, and I want to help them build a language for that XYZ domain, how would I go about that? I mean, you mentioned the term schema. I mean, how do I do that?
Okay, so defining a schema really just starts with identities, and we need to give names to things. And in any given problem space, the people that are already involved in that, in solving problems in that space, usually will have a fairly rich and deep language that they can speak about their problem space in. And so we just need to capture those words, those identities that they are familiar with and comfortable with already. And so the real key is to just first come up with those important concepts from our domain and represent those using, as I mentioned earlier, we have a domain already defined in the system for defining domains. And so it has its own, set of words and identities that we as domain developers have to become familiar with and comfortable with. And so it starts with something we call a domain def. Mm-hmm. And a domain def allows us to describe, in a simplified form, it's a collection of defs.
Right.
And def is another identity in this domain for defining domains.
So defs are kind of the meta classes, and the domain def is a kind of package, if you will.
Right. Yeah. Sure. The domain def, yes, is the collection of meta objects.
Yeah.
And so for each important concept that we identify in a domain, we can create a def to represent that concept.
Mm-hmm.
And once we're comfortable that we have a pretty good idea of what all of the concepts are, we can start moving into the relationships between those concepts. What is kind of the primary concept here, or are there several primary concepts, and we can create relationships between them using field defs. And so we can describe the fields, the parameterization of each concept in the domain of each def using field defs, wherein we can say, for this given field of this def, these are the other kinds of defs that can be put in this field. Some things may contain numbers, other things may contain a list of different kinds of defs. And there's a lot of freedom there to, describe, very restrictive or very free domains, because, different domains have different needs as far as one of the concepts we like to use a lot in intentional software is degrees of freedom.
Yeah.
And there's an appropriate degree of freedom for each problem that you will encounter in a software system. And the goal of intentional software is to provide the exact right degree of freedom for solving that problem, so that the person who is solving the problem, the person who eventually is writing domain code or describing a system using this language that we create, has all of the freedom they need, but no more than that.
Well, and on the other hand, they shouldn't have. Well, you have to be able to write generators by consuming the models or domain code they write. So each of the degrees of freedom that is in the system must be meaningful, and you need to know how to treat it and what to do with it. So that's maybe another constraint here.
Absolutely.
Okay.
But I think one of the advantages of the intentional tree is that it provides us such a rich yet common framework for building these transformations that it's actually, in my experience, I found it's pretty difficult actually to design a language or to come up with a notation or languages that somehow make it difficult or impossible to generate code. That I think it's typically what you find is that given the freedom to really manipulate these trees and alter them and transform them into other trees, that you usually don't run into any issues with the syntax that you come up with.
No, not technically, but I mean, you just need to know the semantics of what all the stuff that people have freedom to write actually means, so you can meaningfully translate it to something else. That's what I was pointing at.
Right.
Okay, so we have defs, we have fields. That's kind of schema definition. That's what you would do. Well, not exactly the same way, but kind of the same way if you did a UML meta model or something.
Sure.
What else do we have? I mean, at this point, we just have a schema. We can't edit things yet.
Right. We have some built-in projections in the system that allow us to project any intentional tree based on a schema that's been designed.
Like a generic tree thing.
Right. So once you have your schema defined, you can immediately begin creating documents based on that schema using a very generic tree-like set of projections. But yes, then you can begin to define your own projections that more closely match the notations of the domain in question. And there is a language we have for describing projections called, we call it the A language, for abstract syntax notation language, abstract language A. And the A language is a set of definitions, defs, that our system understands how to transform further into the various notations that you can put on the screen, such as tables and charts and graphs or stuff that looks like programming syntax, paragraphs and chapters of text, the mathematical equations that we mentioned earlier, and trees.
Yeah. So projection is basically a model-to-model transformation from your own domain to an existing domain that can be rendered.
Exactly. We have the A language, and you transform. You write transformations, and we have a fairly templated capability for doing the transformations where, similar to XSLT, that sort of a system wherein you can transform through these sets of rules one intentional tree into another, and in the case of a projection, it's into a tree in this A language, which is then renderable to the screen or to for printing or even into text files in the eventual case of generating source code.
Yeah, and the A language, as you said, is on the level of table, cell, assignment kind of thing.
Right.
How is that then actually rendered? I mean, is that transformed further, or what's the abstraction level at which you actually draw the lines and pixels?
So we have internal to the system, there is a series of transformations that takes the A language that is produced by domain to A transformations, the projection transformations, and eventually draws that on the screen. And yes, we have a series of 3 different languages that we move through, and depending on the eventual goal for the output, some of the languages we move to toward the end can vary. But for the most part, the A language goes to something we call the C language, which is a concrete language, like a layout language, something similar to LaTeX, I suppose. Would be a good analogy for the C language. And then from that language, we now have a very nicely structured, we know how tall the lines of text are. We know the layout of graph nodes and their connections. From there, we transform into something we call the G language, which is our graphical language. And then that language, in turn, is something that's, down to the pixel and color and Z order and all of the the necessary information that we can actually call the rendering API of the OS to actually draw the images on the screen.
I guess probably it is or was probably quite a challenge to make that stuff perform well, because I mean, if you change something on the projection level, 1+3, you change it to 1+2, you have to go through all these levels and then actually render the pixels differently.
Yes, it certainly is, and we've really, that's a big part of where our time has been spent on intentional technology is really making the underlying transformations perform. And a big key there is partial transformation. We have the ability to recognize which parts of the tree are actually affected by changes in earlier trees in the transformation pipeline, is what we call it. We call it a pipe of transformations, where each stage of the pipe is a transformation from one tree to another.
Right.
And so by detecting the smallest possible sections of each tree that can be sort of altered by a given edit, we can really improve the efficiency and speed of doing these projections.
Okay. Now we have schema, we have editor definition by projection. I guess there are 2 more things missing at least. There is validation, what's typically called probably constraints or something. I guess you have something for that too?
Sure. We have a validation API that you can associate validations with the definitions and fields in your schema that can have any number of various sorts of constraints that you can apply, as in terms of the kinds of definitions that can actually be referenced in a given field. When you start to have languages where the domain actually describes things that will be then referred to from other places in the domain. I mean, the obvious example in programming is you define a procedure or a method on a class, and then you're going to refer to that from other places.
Yeah.
And so you start to have scoping rules about, am I actually allowed to refer to this procedure from this place in the tree? So all of that can be handled via the validation API.
Mm-hmm.
And then we also do have a what we call a type calculus API as well, that allows you to actually assign a type system to the instances of definitions in your language, and provide validation for an actual static type system as well.
Yeah, things like you can only add numbers and not a number and a string, things like that.
Absolutely.
Yeah. Okay. I guess the last step that's kind of necessary for systems like that is what's probably called code generation. How does that work?
So code generation in intentional software right now has a couple of different forms that it can take. There's the primary form that we choose to use is just very similar to what we do with projections. And in fact, the typical last stage of most of our code generators is in fact a projection.
Okay.
So we start out by just doing a transformation, much like the one we described earlier, from the domain of the problem space to some other domain, and typically that other domain is a programming domain, a programming language domain, such as C# or Java or Ruby.
Okay.
And so we have defined schemas for those other languages in our system, and then we can target transformations of the domain code to those other languages in much the same way that we did to do the projections from the domain to the A language.
Mm-hmm.
And so that provides a sort of first stage of create a Java tree or a Ruby tree from my domain. And now we can just transform that Ruby or Java tree using a projection to a notation that is valid code for that domain. So we can through the series of transformations choose constructs in the A language that generate valid Java text or valid Ruby text. And then we have a replacement stage at the end of the pipe that, rather than going to our G language, which is then renderable to the OS's rendering engine, we can actually instead just take our C language and go directly to a text file.
Okay. Mm-hmm.
And then from there we can hand that text file, or a collection of text files, if you will, and generate, hand that generated output over to the compiler or interpreter of the target language for execution. Yeah.
So in some sense, the code generation is projections that aren't executed in real time, but only on demand, basically.
Exactly. Mm-hmm. And and then the other approach that you could take, for certain specific situations is to just write code that simply walks the intentional tree of your domain and makes calls to your own API or builds any other source or tree from that from the intentional tree.
Yeah, and I guess one of the languages you have in your system is a text language, which contains of things like character, word, line, and in the worst case you can always kind of transform to that and just serialize it.
Oh, absolutely. Yeah. Absolutely. You could just transform directly into we have a text editing domain that you could choose.
Yeah.
And then you're of course on the hook for a lot of the formatting, which, if you choose, typically I think even if your target is a language that we don't already support, I think you'll get more value from representing it as a domain first and projecting that domain, rather than than trying to just go directly from domain code to text.
Yeah.
But there are situations where it can work. If you have just, the domain code is simply trying to generate, configuration files.
Yeah, exactly.
So, for a system that will process those files.
Yeah. I'm thinking of OSGI manifests right now, so I guess, yeah, whatever.
Sure.
We talked about the fact before that you, for one intentional tree, you can have different views, different projections. Does this also include the possibility to have, for the same concept, different projections, or maybe even project the same thing differently in different contexts? Is that also possible?
The same thing differently in different contexts. Yes, absolutely. We certainly, you can define many different projections for the same domain. I think maybe that's the question you're getting at, or
that's the
and you can also define properties that can be applied to the view in order to parameterize the projections to produce different results. You can, there are many built into the system. For example, changing the background color or foreground color of the projection, or changing the font size, or the actual font. Things like that. But then you could also introduce your own properties that actually parameterize your domain projection. That might say, okay, if the user chooses to turn on this property on this node, then I'm going to project it as a table rather than a graph.
Okay.
Or something of that nature.
And of course, things are always editable because it's not a visualization; it's actually a live projection. Just
Absolutely.
To re-emphasize.
Yes.
Okay.
And in fact, even one of the nice things with using the transformations and projections for the code generators is that we can actually produce editable views in the target programming languages. I can have a domain code that targets Ruby, and then actually show that in the editor in its Ruby form, and then perhaps edit additional fields of that domain tree that may not be available in the domain code projection, but are available in the Ruby projection. Or add additional code annotations, add additional code into the tree in that Ruby projection, because it is all editable.
That's an interesting way to look at it, because assuming the Ruby thing is really just a projection of the same intentional tree without any transformation, then I can easily imagine how that would work. But if you create the Ruby representation by actually really a transformation, and then you change something in the result of the transformation by adding additional code, then if you retransform, is that code not overwritten? I mean, how do you invalidate the results of transformations? I guess that's what I'm getting at.
Well, there will certainly be parts of any transformation that may not be editable, because they spring into existence in the transformation.
Yeah.
Right. So there's very likely to be some constructs in the Ruby projection, if you will, of some domain that is not editable.
Yeah. Okay.
In that view. However, we can make the projection, basically in the way that we do our projections or our transformations, we can provide the adequate mapping and editing rules during the transformation, such that we can actually make those edits and have them go into that underlying intentional tree, which, remember, we said can contain any fields. The schema of our language is never controlling the actual underlying storage structure, but is actually just describing a particular layout for a tree to participate in that domain's capabilities.
So some nodes in the tree might come from the schema defined for, let's say, some insurance domain, and then other nodes come from a Ruby domain, which you use to add additional, quote, manually written code to the stuff transformed out of the insurance stuff.
Right.
Okay.
Exactly. And then your insurance projection can safely ignore the Ruby code that it does not understand and not present that to the insurance expert.
Yeah.
While the code remains in the overall domain structure of the underlying tree for the programmer's purpose.
I guess if your insurance projection is guided by the schema defined for the insurance domain, then it kind of doesn't even see the other stuff. It is in some fields, but it isn't aware of it. Yeah.
Right. And we actually we have the ability with our own underlying projections to sort of enhance, if you will, the projections that people write to actually show the underlying stuff in the same view,
right?
In a sort of default way that I was describing earlier. We can, you could be looking at the insurance specific notation and say, boy, I'd really like to see the Ruby code that's underlying this here, and sort of turn that on, and we will inject that transformation into the insurance projection.
Mm-hmm. So switch gears a little bit. Which technology did you use to actually implement the intentional system? Is it bootstrapped, or what is it based on?
So there's an underlying kernel of the intentional system that was developed in .NET with using C#.
Mm-hmm.
So that provides this sort of very basic underlying core. And then some of the lower level transformations, some of the later stage transformations that I was describing, the C language and G language transformations that produce the structure and call the rendering APIs, are in fact implemented in C#.
Mm-hmm.
But much of the system is actually bootstrapped in terms of all of the definitions that we rely on for those languages are in fact implemented and edited using our intentional domain editor,
mm-hmm.
the intentional domain workbench. So we do in fact have a significant portion of the system at this point bootstrapped into our own technology, where we can define new intentional domains and enhance the capabilities of our editor using its own technology.
Okay, so let's switch gears again and take a look at the existing prototypes / customers / applications. Can you give us an overview of which kinds of systems you've built or are willing to talk about or are showcased or something?
Sure. We've done, it's pretty common knowledge, I think we've done several demos and presentations that have included a system in the pension administration space with Capgemini in the Netherlands.
Yeah.
And we've also had several different people using the system for evaluation purposes, looking at ways that they could include it in projects that they might have upcoming, or in other ways that they might be able to take advantage of the technology. And we've got another system that is getting a project getting underway in Europe that is an information modeling system in a medical domain.
Mm-hmm.
And I am currently working on a domain for a customer here in the United States that's based on a forms and interviews for complying with some regulations.
Mm-hmm. Okay.
So the domain expert in the case of that particular example is someone who's well versed in the legal and aspects of complying with the laws and regulations, and can sort of provide this expert flow through an interview that helps someone who is in no way an expert. The end user of this application is intended to be just a random person at a company who they need to they've been tasked with the job of helping their company comply with these regulations, and they could greatly benefit from having, some expert knowledge provided to them that helps them sort of walk through a series of questions that lets them drill down to exactly the information they need to provide and what form they need to provide it in.
Yeah.
And so it's a pretty exciting domain where we can really, describe a language of, these sort of series of questions and pieces of information that need to be captured in a way that, the domain experts who are, these legal experts can actually just sort of write, this flow of questions almost as if they were just editing a word, a document in a word processor. And then we can, generate a full-fledged web application from this information to deploy out to the end customers.
Going back to the pension domain, can you maybe illustrate a little bit the different notations used in that system and why? Well, and kind of how that exploits the capabilities of the intentional tooling.
So the pension domain involves defining a lot of concepts around pensions, the rules of administering pensions, and defining, when people's pensions take effect, and what their actual benefits are over time, and all incorporating all of the laws and rules and regulations of, in this case, it was the Dutch government.
Yeah.
And so there are notations that are sort of very basic, decision tree type notations, where we have, effectively simplified if-else ladders. I mean, in some sense, it's very similar to real programming.
Yeah.
But the form of the language, again, the degree of freedom is restricted in a way that makes sense.
Yeah.
For the pension, expert.
Right.
And then there are a lot of tables in that domain. It has a very strong temporal aspect to it, where the rules can change over time. And so there's tables that sort of provide a projection that shows, well, for this time range, here was the rule. For this time range,
right.
here were the rules. Here were the components involved.
Yeah.
So there are a lot of tables, and then and also tables were used for presenting. In that particular domain, there was a strong testing aspect of, they really wanted to be able to have an integrated testing of the domain code and the information that the domain experts are providing, which is something that our system can do really well, because the evaluation and of test data against the rules can just be another, sort of projection and transformation. And so we had tables wherein they could define the test inputs for, representing, say, a particular pensioner, and then the results of the applying the various rules to that test input would show up next to the rule in a tabular form. And then we also had, because it does have that sort of, if-else-if structure to it, to the code, there was actually a debugging projection that broke out the if-else projection into a more graphical tree-like notation.
Yeah.
And provided so that the individual components of the calculation and the decision tree were actually shown each in their own graph node.
Right.
And with the result of evaluating that particular statement with a particular test data input.
Yeah, so you could kind of follow through the calculation as it progresses.
Right. It's sort of like, it's just as if they had sat and used a desk calculator to sort of do the calculations and make the decisions, and they can just see the result of each step of the process, so they can, track down the error without having to, without the sort of, thing that programmers are accustomed to, which is the line stepping debugger that we're also, in love with.
Of course, this works especially well if you have like more or less functional languages, right? I mean, in some sense, that's the only way to debug functional expressions.
Absolutely.
Yeah. I seem to remember from the presentations that there is also some mathematical notations in that system.
Yes, there are mathematical notations. There's the part of the input actually comes from actuarial specialists.
Yeah.
Actuaries that define the underlying rules that extend into the rest of the system, and they actually have it's not so much mathematical. It's actually a very specific notation. It's really interesting that actuaries actually have a very specific notation that includes its own set of symbols and identifiers.
Yeah.
That we were able to capture, and again, it's something that people probably need to see in a video or a capture to get a full flavor for it. But there's a lot of really little intricate bars and lines over letters and superscripts and subscripts that have very significant meaning to people who understand it.
Yeah. Yeah.
And again, that's sort of the beauty of the whole thing, is that we as programmers sometimes get almost forced into becoming actuaries in order to develop a system that supports actuaries. And I think in this, one of the things that intentional software does very well is it allows the programmers to sort of stay focused on the programming and the support of the domain experts and the code generation, and not have to sort of really come to fully understand maybe the notation. I mean, clearly you need to have a full understanding, like you said, of the schema and the semantics in order to do the code generation.
Yeah.
But you don't have to sort of keep in your mind, you can provide this very rich editor that has these bars and lines and superscripts and subscripts without having to sort of keep in your head what those particular things mean. They have very deep meaning for the people who understand them. And so it's really nice to be able to give a tool like that to someone that has, this deep meaning for them.
Yeah.
And then is at the same time, providing you with this great, underlying tree that you can be very comfortable with transforming and generating, other output from.
Yeah. Of course, at some point, somebody has to understand the domain to be able to define a schema and stuff. But I guess you do that once, and then you can delegate all the detailed work of actually putting in the data. That's what the domain experts then do.
Sure. I mean, it's you have to understand it from the point of building a language around it, and there's no it's no joke that there's certainly a skill there that has to be mastered in terms of taking this. Yeah. And I wouldn't say that you do it once. I think it can be a very iterative process.
Oh yeah, sure. But
I think the nice thing about it is that it is much more collaborative than in many other situations, where you can actually sit down with the domain expert and you can define the language, right there with them, and begin to sort of see it take shape and take form, and get their immediate feedback and work through the different situations and issues that will come up.
Yeah.
And it can be it becomes a very fluid process, really. And I think over time, the nice thing about it is that you don't. One of the things that I really like about the intentional system versus some others that might be out there is that you don't have to have any concern for the language or what your end user wants to represent. You don't have to worry about coming up with something that's parsable.
Right. Yeah. Sure. Yes.
Right. Mm-hmm. I mean that is such it provides such a nice freedom.
Yeah.
To not have to always be concerned with, well, we're already using that kind of symbol here, so now we have this conflict, and there's sort of a this great degree of freedom to that really matters in that particular case, which is really being able to capture exactly what your domain expert is telling you and not having to make unwanted compromises.
Yeah. So if you have this rich notation, which is not parsed, so it's not ASCII text, how do people actually edit things in these projections? I mean, is everything click mouse wise, or how does that work?
Well, we have built, various keyboard navigation mechanisms for navigating the trees, and so you can, use the keyboard. There is a lot of clicking, and it depends on the domain and the situation and the comfort level of the user in terms of how they tend to use software and how they tend to interact with applications. And of course, software developers tend to be the most demanding domain experts in terms of the kind of freedom and flexibility they expect from editing their documents.
Mm-hmm.
And in the other in many cases with the more domain specific projections and notations for end user domains like the pension domain or this interview domain, we can actually just provide the necessary click points on the screen. Click here to add this kind of question, or click here to add some new test data, and drop downs and radio buttons and things like that allow people to choose their inputs or the structure of the language that they're trying to produce.
Right.
So, but we do have, and in fact, the next version of our system that we're currently working on is going to actually include a much more robust keyboard navigation system that allows much more geometric style of keyboard navigation than we've had in the past. In the past, we've had our keyboard navigation has more closely followed the structure of the projected tree.
Okay. Mm-hmm.
And not necessarily the domain tree, but the actual the structure of the A tree that you've produced in your project.
Yeah.
And this worked, and it works quite well for a lot of domains, but there are also situations where it just becomes sort of cumbersome and puts an unnecessary the wrong burden of understanding on the user in terms of knowing sort of the underlying structure of what they are looking at in order to get to the place they want to be using the keyboard.
Mm-hmm.
Whereas in the new navigation system that we're about to deploy actually provides a nice on-screen cursor, and you can up means up and left means left.
Cool.
Right means right, and you can navigate around in that way, and it's just using all of the information we have from all of the trees through the pipe to sort of get you to the right place based on what's underneath the cursor when you move there.
Nice.
And there's it's so far seems to be providing a much more fluid, more text-like editing experience in the domain tree. So we're pretty excited about it, and we feel like it's going to be a really great usability enhancement moving forward. That may have it'll allow us to get into even more complex domains than we've already been able to get into because of the kinds of tree structures that might be represented.
And it might convince certain skeptical programmer types who don't want to use the mouse all the time.
Absolutely. This next version is much more friendly to the I want to keep two hands on the keyboard.
Cool.
Style of work.
Very nice. I'm looking forward to that. And maybe I should have said in the beginning that that I was once working for Intentional as a consultant, and that I actually currently playing with the tool. So I do have some bias or whatever you want to call it. And so I'm looking forward to getting my hands on, literally my hands and not my mouse, onto the new version.
Right. Yeah. Well, I think people who have used the system in the past, I think will really appreciate it. I think for someone like myself, I've actually become so accustomed to the current use model. I mean, it does work. The model we have today works. It's just very different from what people are used to in other software. But I've been working with it for several years now, so I'm actually in a position where I'm going to be sort of unlearning the less desirable approach, and we'll probably actually stumble a little bit with the new one. But I think all of the feedback that we're getting from early users and some of the other people on our teams that are using the new stuff is that it really works nice, and it really it gets you to the point where you can really start to forget about the fact that there's some underlying structure to what you're editing.
Very, very good. Okay, so let's close this discussion off by going back to the very beginning and maybe very briefly covering the history of intentional programming and intentional software, and then look at the current state of the system. So where does this thing come from? How long have you been doing it and stuff?
So intentional software is a company that was founded by Charles Simone in 2002. And prior to that, it was actually a research project at Microsoft Research.
Okay.
And Charles had led that effort there for several years. I actually can't recall exactly how long off the top of my head right now, but they and they made some nice improvements there. They came up with some good ideas. They got a certain distance with the system, and then Charles decided to move on to try to move it forward as a separate company.
Mm-hmm.
So they started with intentional software in 2002, and the system has been through several generations now internally to the company as we've worked through various technical issues and trying to get the technology, as you'd mentioned before, making the series of transformations performant such that it's actually capable of being a sort of real-time editing environment has been a key challenge, and we've gone through several iterations in both trying to improve the performance, and also just I think one of the key things that happened along the way is we really improved the flexibility of the series of transformations to really involve any number of domain to domain transformations, and any number of languages or schemas being involved in any given tree in order to project it to the screen or to a file. And I think that is really that has really been the key in making this, sort of rather than just being some kind of a, interesting research project, to making something that's, viable for developing, production software.
So it is released as version whatever 1 point something, or is it?
We're currently on 1.5.
Okay.
And the new version upcoming that I was talking about will be 1.6.
Okay. And can people get it, or what's the process there?
People can get it. There's you can go to our website and communicate with Magnus Christensen, and there's a process in place for getting signed up to get an evaluation license going, and or to talk with us about working on projects together.
Okay, but there is no download for everybody to play.
There is no download right now. We can there's not a go here to just download it and try it out. But it is available upon request.
Good. Okay. Well, as I said before, I'm certainly very biased. I think this kind of approach is a very, very, very interesting approach to doing things. We've had a short episode on JetBrains MPS before, and your stuff is certainly similar in from the conceptual perspective, and in my view a little bit more flexible and more extreme in the positive sense.
I think we're targeting they're slightly different, target audiences in that I think, the JetBrains tool is really, and I think it's a very good thing that they're really, trying to get the benefit of domain specific languages into the hands of programmers.
Yes. It's clearly a developer tool.
And it's and that that definitely has a lot of value. I think that this pattern of getting the language that you are developing your software in closer to the domain is just a very powerful tool, and it's something that everyone should consider.
Yes.
And we just we're sort of taking this additional step of saying, well, if we have the right technology, then we can put these notations into the hands of the domain experts and cut out that sort of next step of inefficiency and confusion and source of error, which is that sort of the inefficient communication between the people driving the requirements and the people building the software.
Mm-hmm.
If we can get the people driving the requirements more involved directly in building the software, then the likelihood of a positive outcome becomes much greater.
Yes. I was about to ask you for a bunch of closing words, but I think what you just said is actually a very nice summary of what you're attempting and what you're doing. So, I mean, you can still add another bunch of closing words, but if you don't want to, then I guess those qualified.
Well, I think that seemed like a pretty good summary to me, too. So I guess we'll just leave it at that.
Okay. Then I thank you very much for being on the show. And,
thank you for the opportunity, Marcus.
Sure, and looking forward to the left means left navigation.
All right.
Thanks. Bye.
Bye.
Thanks for listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example, by clicking on the Dig Reddit Delicious links and the /dot button. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsive Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.